element values are more zeros than any other non-zero values, then we can call that as a sparse matrix. When the traversing is got over, once I reach the last element, though I didn't found any of the searching element, then I can say that search is unsuccessful or element not found. So if it is exactly at the middle, return the middle position, which is left side or lesser than the key element, only go with the left part of a key. If it is greater than the key, go with the right part of a key. Hello everyone, welcome back to the session 3 of chapter 1 in the unit 2 of B.Ca second semester subject called Data Structures Using C. So in this chapter, we are going to discuss about the searching concept. I am Rohini T.S., Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. As we all know that in the last session of this chapter, we had a discussion regarding sorting, that is arrangements of elements either in ascending or descending order, and also we got to know the different techniques of sorting that includes bubble sort, quick sort, selection sort and insertion sort. So in our today's session, we're going to learn about the searching techniques and we'll see what you mean by searching. Then we're going to see about these two techniques, that is linear and binary search. First, you need to understand the definition of searching, what we are searching for here. So, searching is a process of finding the location of an element. So, if I have a large number of data elements, amongst that I wanted to find only one element. I wanted to know its position or a location. So, that is what we are going to do in the searching. The process of finding the particular item in the large amount of data, then we are calling that as a searching. Or else the process of finding the location of a particular element. I am finding the location or position of an element in the set of elements, then we are also calling that as a searching. And what are the different techniques we have? We have a sequential search or linear search, then we have a binary search. We'll see the first methodology. This has two synonyms here. Sequential search is also considered as a linear search. Already you know the meaning of linear, one by one. It will be in the order. So we are searching an element from the first element to the last element. So if I am finding that element, then I can say that element found. So if I am searching from the first element to last element, if I didn't found that element, then I can say that search is unsuccessful or element not found. So here you can see that a sequential search is a simple searching technique. Why? Because in this technique we search for a given key item in the list in a linear order, that will be in the sequential order. That means what? Here one after another we are searching one element. If it is matching with my key element, then I can say the element is found. If not, then I will go with the next element. So that the item search is often called as a key item. The item which we are searching will be considered as a key item. And also we call this sequential search as a linear search. So here you can see the example. I have a 5 elements 50, 40, 30, 60 and 10. So you just imagine I just wanted to search the element called 10. Where it is now? So you can see the position. It is in the position 4. That is in the 5th element. And I have a certain item called 50, 40, 30, 60 and 10. So now what we are going to do? So I just consider this 10 as my key element. Let me consider key is 10 right now. Then I will make a comparison with all other elements from the first element to the last element. So here I will make a comparison. Is 10 is equal to 50? True or false? False. So this is not the element what I am searching for. Next I will come here. Is 10 is equal to 40? True or false? False. This is not the element what I am searching for. Next, is 10 is equal to 30? No, right? This is not the element that I am searching for. Again, I will come to the next element. Is 10 is equal to 60? True or false? It is false. This is not the element that I am searching for. At last, I have one more element called 10. 10 is equal to 10. True or false? Yes. So here search is successful. I found an element which is there in the position 4. That means this will going to return the position or a location of an element which we are searching for. So at last what it will going to return? Element found in the position 4. So if I am searching for a value called 70, Then I'm going to make a comparison of 70 with all other. Is 70 is equal to 50? No. 70 is equal to 40? No. 70 is equal to 30? No. Is 70 is equal to 60? No. Is 70 is equal to 10? No. So at last what it will going to return? When the traversing is got over, once I reach the last element, though I didn't found any of the searching element, then I can say that search is unsuccessful or element not found. Fine. This is how we are going to search by making use of this linear search. And here you can see the function we have for the linear search. Int linear search, int is a return type and name of the function is linear search, and I require an array and I wanted to have a key element to make a comparison, and I have a iteration, that is I. Then I need to find the position of an element. So for I is equal to 0, I less than n, I plus plus. So here what we are going to do, from the first element to the last element we are making a comparison. So when the I value is equal to 0, then it will check for the first element. So if that first element is equal to that key element, then it will going to return the iteration, that is what is the position that it will going to return. So if this condition become false, until that for condition become false, the loop will going to be executed. That means it will going to traverse till the last element of a set of elements. So if this become false, then it will going to say is that the element not found. Otherwise, it will going to return the position here. This is how the linear search or a sequential search will going to works in a C programming of a data structure. Next, here you can see the advantages and disadvantages. As we all know that it is a simple approach. We are just going to search by making a comparison with all the element and works well for the small list. So if it is only 10, 15, then that would be okay. What if it is lack of elements we have? If that is in the last position, then I need to make a comparison of all the other elements. So it is only suited for a small list and used to search when the elements are not sorted. So here we don't require the element needs to be sorted in order to search. That is not in the criteria of this linear search. When it comes to the disadvantages, what and all we have, it is less efficient if the array size is too large. As I told earlier, if the elements are latched together, then the comparison of all the elements is somehow difficult. At the time, it is not so efficient. If the elements are already sorted, linear search is not efficient. So if it is already sorted and if you are searching for a particular element, then it would be not so helpful. This is what linear search or a sequential search. So now we'll see about the second technique, that is what binary search. This is one of the simplest method here. So in which it can be applied if the elements to be compared or either in ascending order or descending order. You need to remember one thing. So when we are having this binary search, at the time input must be the element, set of element which we are giving should be in sorted manner. I can say it can be what ascending order or descending order, but it needs to be in the sorted manner. Then what is the procedure in order to do this binary search? We'll see here. So here we are going to use two terminology. One is low and another one is high. So if I wanted to search from where to where, I should know the boundaries. Then I need to consider the first element as a low and the last element as high. So in between that first and last element only we have to do the searching. That's why I'm considering the low and high. Low is considered as the position of the first element and high is considered as the position of the last element. And we have to find out the middle element. So if I wanted to search, so in order to make the searching simpler, we are finding the middle element. I know the first and last and I am comparing or I am making a middle element. And how we are going to find the mid element? So for that we have a formula, low plus high whole divided by 2. So this is what the formula to find out the middle of an element. So if I wanted to get to know the first element, low. If I wanted to know the last element, then high. If I wanted to find out the middle element, I need to add low and high, then whole divided by 2. Then we'll see one extra example to make you understand how this binary search will going to work. Let me consider. So here I have 3 elements 10, 20, 30. Its positions are 0, 1, 2, right? So what is the location of the first one? 0, and I will consider that as a low and last element is considered as high. So now I need to find out the middle element. How I am going to find? Low plus high divided by 2. What is the low position? 0. And position of high is 2. So 2 by 2 will be 1. So this I can directly say that this is the middle element. So what if I have 4 elements? Then it will be 0 plus 3 divided by 2. It will become what? 1.5. You should consider that as 1, not 1.5 or 2. So we have to consider the position 1 as a mid element if we have a 4 elements over there. So in this method we are going to find the mid element. And now I wanted to search for the element called 20. That is what my key right now. So now my key element is 20 right now. So here I am going to make a comparison. If key is equal to A of mid, if I am searching for the element which is exactly at the middle, here we have a 3 scenario. If I am searching for the element which is exactly at the middle or which is left of the key element or a middle element which is right at the middle element. The 3 scenarios we have. Amongst that, first I am looking for a key element which is exactly at the middle. So here you can see that. What is the condition? If key is equal to A of mid. What is the key? As I told earlier, it is 20 is equal to A of mid. That is A of mid in the sense A of 1. What I have in a A of 1? That is 20. So is 20 is equal to 20? True. If it is true, if I am searching for the element which is exactly at the middle, then it will going to return the middle position as a position. Position is equal to mid element, where it is in the position 1. Element found. That means search is successful here. Then we have to return. What if I am searching for the element which is right side or left side of a mid element? For that also we have a scenario here. After executing the statement, if they are equal, then the position of the mid item in the array will going to be written. So if not, if the condition become false, then what will going to happen? Key may be in the left part of the array or in the right part of the array. If it is not exactly at the middle, then it must be at the right side or at the left side of an array, right? So if the key is less than the mid element, if I am searching for the element which is lesser than the mid element, let me consider the same example. 10, 20, 30, 0, 1, 2. So as of now, in the first scenario, I had taken key as 20, that is exactly at the mid. Now let me consider element which is left to the mid element. This is what mid, this is low, this is high. Okay. So now let me consider the 10 as my key. In my second scenario, I am considering the key element as 10. Okay. So if the key is lesser than the middle element, then the table in the left part has to be compared from low to mid minus 1. So now from where to where I am supposed to compare? If my searching element which is lesser than the key element, key is 20 and my value is 10, it must be in sorting order. 10 is lesser than 20. True. Then I need to make a comparison only to the left part of a given list. And if it is greater than the mid element, then I need to do the searching only with the right part. As of my scenario, I am searching for the element called 10 which is left of a middle. So I need to compare only the 10 value. So now it will become low, mid minus 1 in the sense 1 minus 1 0. So this will be the only low as well as high element, and 0 plus 0 will be 0, 0 divided by 2 will be 0 itself. This become the low, high as well as mid. Then if I am searching for the element which is exactly at the middle, yes, 10 is equal to 10, then it will going to return the position 0. Okay. What if I am searching for the element which is right side or which is greater than the key element? Then the right part of the array has to be compared from mid plus 1 to high. So here mid is this 1. Mid plus 1, then this 2, the position 2. Just imagine I have one more element, make it as 40 and let me consider as high. Let me write it here itself, 1, 2, 3, 4, 10, 20, 30, 40. Okay. So as of now, I wanted to find the location of this 30. Let me consider my key as 30 here, and this is what low, this is high, and this is the mid element. Fine. 0, 1, 2, 3. My key is 30 right now. Consider only this scenario right now. That is scenario number 3. Scenario 1, which is exactly at the middle. Scenario 2, which is left of a key. Now it is right of a key. So here 30 I wanted to search whether it is found or not. Then here, if that is the condition, then we have to make a comparison only mid plus 1 to high. Mid was 1, mid plus 1 in the sense what? 2 to high, then 3. Only I need to concentrate 30 and 40 and I should not bother about 10 and 20 in order to search 30. Fine. Then how it will going to look like? I need to compare or I need to check only 30 and 40 right now. Its position are 2 and 3. So to find the mid element again, then it will be 2 plus 3 divided by 2, then 5 by 2. It will become 2.5. I can't consider 2.5. I have to go with a 2. This will be considered as a mid element. This is my low and this is the high value. Fine. Then if I am searching for the element which is exactly at the middle, yes, that is in the position 2. Why? Because the mid value is 2 and position, the key element which is I am searching is also in the 2. That's why it will going to found or it will going to return element found in the position 2. Okay. So if it is exactly at the middle, return the middle position, which is left side or lesser than the key element, only go with the left part of a key. If it is greater than the key, go with the right part of a key. Okay. So if that is the condition, how we are going to find? If key is lesser than A of mid. So if it is left side, then high is equal to mid plus 1. So which will be the highest value? Mid plus 1. It will be up to there, or else we have to make a low as mid minus 1. We have to start from mid minus 1. So here, from here we have to start. If that is true, then we have to make this as high. In between only we have to make a comparison and we need to search for the element which we wanted to have. This is how we are going to do the binary search. Here you can see the advantages and disadvantages of binary search. When it comes to the advantages, it's somehow a simple technique and very efficient searching technique. Then what are the disadvantages? Mainly the list of elements where searching takes place should be sorted. Either it is ascending or descending order, it should be sorted. And it is necessary to obtain the middle element, which is possible only if the elements are sorted in the array. So if the elements are only sorted, then we can apply this binary search. And if the elements are not sorted, then we can't use this. This is what regarding binary search. We'll see the next topic, that is by multi-dimensional arrays. So till now we have discussed what is one-dimensional array and what is two-dimensional array, how it will going to be, what represented, what are its advantages, disadvantages, applications and operation, everything we got to know. So in this multi-dimensional array, I can say this as an array of array. So why? Because when the array is greater than or which is having more than 2 dimensions, then we can call that as a multi-dimensional array. An array with more than 2 dimensions, then we can call that as a multi-dimension, and we can also call this as an array of arrays of array. So it will going to have a different number of dimensions which is greater than 2. So here you can see the general form or a syntax. First I need to have a data type for this dimensional also, and I need to have a name of an array. That is what? Array name size 1, size 2 up to size n. That means it's not only restricted to rows and column, and also we have one more dimension. That's why it is considered as a 3 dimension. So here data type is what? A type of a data which needs to be stored in the array, and its array name is the name of an array, and here size represents the number of dimensions that we are taking. So if it is one dimensional array, then it will be in this manner. If it is 2 dimensional array, then it will be of table format. So if this 3 dimensional array, then it will be in this manner. It will going to be like this. It will have more than 2 dimensions. So in this manner, you can expect a 3D. This is what 1D, 2D and this is 3-dimensional array. Fine. This is what the representation of multi-dimensional array. And at last we have a sparse matrix. What it means? Sparse in the sense when we have a matrix, or when we have a rows and columns, in that if I have a more element as 0, then I can call that kind of matrix as sparse matrix. A matrix is a two-dimensional data object made up of m rows and n columns. I have m rows and n columns, therefore having a total m cross n values. So if it is a table, then it will be a m cross n values. In that, if the most of the elements of a matrix have 0 value, if the element values are more zeros than any other non-zero values, then we can call that as a sparse matrix. Then what is the advantage of having it or use of the sparse matrix? Mainly with respect to storage. So in order to store non-zero value, that is what integer values, at that time it will somehow require more memory space. If I am storing only 0, then it will require less memory space. So here, if there are lesser non-zero element than the zeros, and thus lesser memory can be used to store only those elements. In order to store the 0, we don't require memory location. So by default, 0 and 1 will be the language of a computer or a binary. So here we require only the memory space in order to store the non-zero element, which is other than 0, we are storing it. For that purpose only we require a storage. And also when it comes to computing time, I no need to bother about a 0. I have to focus only on the non-zeros. So here computing time can be saved by logically designing a data structure which is traversing only non-zero element. We are not focusing on the zeros which are non-zero, which is other than 0. That is what only we are concerning here. So if you see this, here is the example we have. If you consider this, we have a more zeros. Instead of focusing on those zeros, we just need to focus only on the non-zero element, or which is other than 0, that we wanted to focus here. That makes what computing time is lesser and it will require a storage space lesser. This is what you need to learn about the sparse matrix. I hope you all understood my today's session. In my coming session, we're going to discuss about this chapter 2. That's all regarding stacks. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.